Hello, my name is Lilia Wild, and I am doing a presentation for climate change. I'm in the class Understanding Climate Change right now, so this is our final presentation. I'm talking about climate change in Indianapolis, Indiana. So just a little history here on kind of what climate change is. So climate change refers to the long-term shift in temperatures and in the weather patterns that we have. These shifts may be natural, but now more commonly, since humans around the 1800s, our activities have been the main driver of this climate change. This is primarily due to burning of the fossil fuels like coal and oil and gas, which all produce heat-trapping gases, which is our main issue within climate change. So next we'll be talking about feedbacks and forcing agents for climate change. So these forcing agents, these are things that can be changed globally. They're the global temperature directly. So for example, the greenhouse gases, reflectivity, absorption of the sun's energy. And a feedback is a process that can either amplify that or that can diminish that effects of the climate forcings. So funny enough, within these feedbacks, there's two different. There's a positive feedback and a negative feedback. Initially, when I learned this, it got me scrambled because it's not exactly what you think. So your positive feedback is actually the bad one in this case. So it actually accelerates that response. Whatever response is given off from a specific thing, it makes it kind of worse. So an example of this would be, the permafrost melting. That releases the carbon and the methane back up into the atmosphere, which only kind of gets worse over time, especially with methane. Our levels will continue to increase slowly as it goes. The more methane, the more that's released, the worse it is. And so within that, the removal of the high ice albedo, the ocean circulations, and of course one other really main issue right now is the rising sea levels. And then next we'll go into talk about the negative feedbacks, which is actually, again, the good one in this case, which is actually decreasing and stabilizing the climate system. So examples within that would be, increased cloudiness reflects more of that incoming solar radiation. So therefore, it's helping cool that area and kind of push some of that heat back up, because that's one of our issues right now, is global warming. We're getting warmer, the temperatures are rising. That's one of our main issues. Within that, we're looking at wetter seasons, so higher rainfall from all the moisture in the atmosphere, black body radiation, and off to the side here to the left, you can see that little chart of how that all kind of goes into play, and you can see how that positive creates that change and speeds up our warming, where the negative is actually slowing it down, trying to reverse those effects. So next we're going to be talking about some historical context of climate change. One of them I decided to talk about was the Great September Gale of 1815, which was actually the first major hurricane to impact New England in about roughly 180 years. It was originated back in the West Indies on September 18th, 1815. And that slowly kind of spun and moved itself northeastward. Though roughly they say about only 38 people died, the rescuers actually believe that hundreds and hundreds died due to all the damages, due to, some weren't found, all the issues, because within that came, there was a lot of damage. So you're looking at a lot of casualties through that. The next thing I decided to talk about was the Little Ice Age. So that began between about 1275 and 1300 AD. It was triggered by repeated explosive volcanoes and sustained by self-perpetuating sea ice ocean feedback system in the North Atlantic Ocean. Many scientists believe that the Little Ice Age was either caused by decreased summer solar radiation, and said that the erupting volcanoes that cooled the planet by all that ash is covering the sky, and it was ejecting shiny little aerosol particles that reflected that sunlight right back into space. It could be a combination of both, because and anything you can see, anything you look up about volcanoes, and when all that ash erupts, it completely covers the sky. It gets dark. It's really hard for that sunlight to penetrate that area to get through. And research have been looking at the set of the solar radiation at a constant level in the climate models. Let's see. So next, a little bit more in depth into the Indianapolis side of the climate effects that we're having, my hometown. As I was looking, I didn't find too many articles that actually showed or kind of wrote about all the issues we're having. I noticed it's not very, very talked about in our area. Only specific things slightly. So here I have in Indiana, the climate change is having a more severe impact than what I thought, especially with the more unpredictable weather and the more severe weather that we've been having. And farmers now can receive lease payments for developing renewable energy on their properties. An increase in that economic activity in renewable energy will actually offset all the losses that we've had from that coal generation. It plans to have more than double electricity capacity of renewables by 2025. Let's see. So for my next slide, we're kind of talking about some ideas of what Indiana could do to help in those actions. And when I was looking this up, I just could not find very many things that Indiana was truly actively doing. I kind of learned it's more of a political issue, and it's more of a money. People don't want to put money towards, the climate effects that we are having. It's more of the money is going elsewhere, but there are common ideas brought up to put a large amount of sulfate aerosols actually into the stratosphere, which would also, help because they are highly reflective, and they can try to push some of that sunlight back into space, kind of hoping to at least cool our area down a little bit. And so that kind of leads us into the future outlooks for what we're looking for. Indiana is expected to only get warmer with climate change. And it's something I've noticed as a kid is how hot our summers have gotten, how humid and how dry our summers have gotten, versus our winters, where I can remember as a child only having icy, beautiful, snowy winters, and now we're lucky to even get a snowstorm. And in December it's randomly 70 degrees when it's more expected between to be in the teens or the 30s. So stuff like that I can see as a child to where growing up of how bad the effects are. And I never really realized that. I knew climate change was an issue. I knew global warming was an issue. But when you put it all together and you really, and this class kind of helped me kind of piece everything together to be able to see what truly not many people look into, they don't think about. And so I just found that interesting. But here, like I mentioned, there are more risk for fires. So there's a lot of times where, 4th of July, it has to be called off. We cannot have any kind of campfires. We can't have any fireworks. We can't have anything like that going on because the fires would get out of control. And like I said, I do have that point up there to where The summers are becoming more and more intense and more humid. And within that, you're becoming and getting more heat illnesses. And then these are my citations.